The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. Okay, so today we're back on schedule. We're going to do section 2.4 part 2. And I'm going to start with some examples. This first one we have, it says solve the formula for the specified variable. And we have V equals 1/3 pi r squared h. And we are to solve for h. So we have h right here. That's all one term on the right side. 1/3 pi r squared h is all a single term. So that is the variable term. It's already isolated. So now we want to isolate the variable. We need to get rid of the 1/3, the pi, and the r squared. We're going to multiply both sides by 3. On the left side, we get 3v. On the right side, the 3 times 1/3 becomes 1, and 1 times pi r squared h is pi r squared h. Now we need to get rid of the pi and the r squared. They're both being multiplied by h, so we can divide both sides by pi r squared. And the pi's reduce, the h squareds or the r squareds reduce, and we get h equals 3v over pi r squared. And there's the final answer. Any questions about that one? Okay, let's take a look at another example. We have m divided by 2 minus 9.1 equals 2.5b. We are to solve for m. And as I mentioned before, don't change cases. If it's a capital B, you need to put in a capital B. If it's a capital M, you need to put in a capital M. You put in a lowercase when it's supposed to be an uppercase, WebAssign will mark it wrong. So be careful with that. All right, we are to solve this for m. So I'm going to add 9.1 to both sides of the equation. So then I get m over 2 equals 2.5b plus 9.1. Then I'm going to multiply both sides of the equation by 2. On the left side of the equation, the 2 over 2 reduces to 1 over 1. 1 times m is m. On the right side of the equation, we're going to distribute. We're going to get what? 5b plus 18.2. 2 times 2.5 is 5, and b, and 2 times 9.1 is 18.2. So m equals 5b plus 18.2. Any questions there? Okay, let's see here. This is solve the equation for the specified variable 5/6 m minus t equals 9b, and we are to solve it for m. Okay, so the first thing I could do is add t to both sides of the equation. So 5/6 m equals 9b plus t. You may recall, if you took Math 75, that when you have a coefficient that is a fraction, you can multiply by its reciprocal. And I believe we looked at that earlier in this chapter as well. But so I'm going to multiply both sides of this equation by 6/5. Okay. So on the left side, the 6 is reduced down to 1 over 1. The 5 is reduced down to 1 over 1. 1 times 1 over 1 times 1 is 1, blah, blah, blah. And 1 times m is m. On the right side of the equation, we get what, 54/5 b plus 6t over 5, okay? And you could write it that way. You could also do this. You could distribute the 6 and leave it all over 5, so you'd have 54b plus 6t all over 5. It's the same thing, okay? Any questions there? All right, let's take a look at some more examples. It says solve m equals the quantity a plus d times t. And this has two parts. Part A, we are to solve it for t. Okay, in fact, let's do this. Let's go. Part A is to solve for t. So solve this for t. To solve it for t, you could just divide both sides by a plus d, and you'd get t equals m over a plus d. Now, the question might arise, do we need parentheses around the a plus d like that? We don't in this case because the fraction bar groups them together, okay? So here is the first part. The person that asked about this one, you changed d into b. That's what happened there. Okay. Part B, it says to solve it for d. So again, we've got m equals a plus d times t. To solve for d, let's see here, we could divide both sides by capital T, and then we'd have m over t equals a plus d, and then we could subtract a from both sides. We get m over t minus a equals d. And again, that a is by itself. It's not over the t because we subtracted a from the entire side. So here is part B. Okay, so those were some requested ones. Let's take a look at some more examples from section 2.4. Okay, how about this one? X equals, oh, did anybody have any questions about anything before we go on? Sorry about that. Anybody? Nope. Okay. A plus B. If I forget to ask, feel free to jump in and say, hey, wait a minute, can you do these problems? Okay. Solve for the specified variable or expression. X equals a plus b over 2. Solve this thing for b. Well, we can't subtract a from both sides at the moment because a is locked up in the numerator of the fraction on the right side of the equation. But what we can do is multiply both sides by 2. First of all, that gives us 2x equals, and then this 2 and this 2 reduce out, a plus b. Then we can subtract a from both sides, and we get 2x minus a equals b. Any questions about that example? Okay, let's see here. G divided by 0.5 plus 16r equals negative 8t, and it says to solve for g. So I'm going to isolate the variable term by subtract, and when I say the variable term, that is the term containing capital G. So I'll subtract 16r from both sides, and I get G over 0.5 equals negative 8t minus 16r. Then I'm going to multiply both sides by 0.5. So I get G equals, and then distributing, let's see, 0.5 times negative 8 would be negative 4t. 0.5 times 16 would be 8, so minus 8r. So G equals negative 4t minus 8r. Any questions there? Okay. How about this one? P equals AB divided by C, and we are to solve for C. Now, you might think, well, if I can get rid of AB on top on the right, I'm done. But that would be 1 over C. We need C to be in the numerator. So we'll multiply both sides by C. We get CP equals AB. The C's on the right reduce out. Then I would divide both sides by P. C equals A times B all divided by P. Let's see here. How about this one? I equals PRT, solve for R. Well, you could divide both sides by PT, right? Because R is being multiplied by P and multiplied by T. So that reduces down. R equals I over P times T. And that is a capital P. Okay. Let's see here. Let's go ahead and do some application problems. This says credit cards. The finance charge that a student pays on his credit card is 19.8% APR, annual percentage rate. Oh, that's terrible. Determine the finance charges, that is the interest, the student would have to pay if the account's average balance for the year was $2,500. Okay, so we're going to use the formula I equals PRT. The finance charge that a student pays on his credit card is 19.8%. So that's the interest rate, which changed into a regular number would be 0.198. Determine the finance charges the student would have to pay if the account's average balance for the year, so time is 1 year, is $2,500. So we're trying to find I. So I equals $2,500 times 0.198 times 1 year. So going to the calculator, 2,500 times 0.198 times 1 is going to be $495. Keep in mind that there would be units of dollars on that. So if there isn't dollars provided in WebAssign's answer, be sure to include it yourself. Any questions there? Okay. This says campers, as in a truck with a camper thing on it. The perimeter of the window of the camper shell, and there's a picture, but you can't see it, but don't worry, I'm going to draw it, is 140 inches. Find the length of one of the shorter sides of the window. Okay, so we've got this window. And we're told that this distance right here, oops, drew that a little bit too long there, is 56 inches. And we're told that the perimeter is 140 inches. Okay. Well, the formula for the perimeter of a rectangle is 2 times the length plus 2 times the width. We know that the perimeter is 140 inches. We know that the length is 56 inches. Okay, so far with that? So 140 equals 112 plus 2w. To solve for w, we'll isolate the variable term by subtracting 112 from both sides. Let's see, 28. And then dividing both sides by 2, and including the units, the width is 14 inches. Any questions about that problem? Okay, next we have a, what is this, a triangular kite. And let's see, this is called the wingspan. Okay. It says 650 square inches of nylon cloth were used to make the kite shown. 650 square inches. If its height is 26 inches, so this would be the height. What is the wingspan? Okay, so we're told that the area is 650 square inches because it says that's how much cloth, nylon cloth they used. The area of a rectangle is 1/2 the height, or excuse me, 1/2 the base times the height. You could say height times base because multiplication is commutative, but I'm getting ahead of myself there. All right, so what have we got? We've got 650 equals 1/2. The base would be the wingspan, so we don't know that, and the height is 26. On the right side of the equation, I can reduce the 26 over 2 to 13 over 1, and I get 13b. Any questions there? Dividing both sides by 13, let's see, if we take 650 divided by 13, we get 50. So the wingspan would be 50 inches. Okay, any questions there?
Yes, so just to be clear, with what you did to get 13 from 26, you simply had 26 on top, 1 on the bottom, and then you just simply divided by it, right?
Okay, let's go back and look at that. I believe the answer is yes to what you said. So the 26 is like 26 over 1. This is all multiplication. So it's the same thing as having that.
Okay, yep.
So the 26 over 2 reduces to 13 over 1.
Okay,
yeah.
Yep.
Okay. Any other questions on that one? Okay, let's take a look at one involving a circle. It says archery. The diameter of a standard archery target used in the Olympics is 48.8 inches. So if we've got this archery target, lovely looking circle there, it says the diameter is 48.8 inches. Okay. Find the area of the target. So we're dealing with a circle, though it doesn't look like one. The area of a circle is, what is it? It's pi r squared. Now, we're given the diameter of the circle. Recall the diameter is the distance all the way across the circle. So if the diameter is 48.8 inches, the radius would be half of that, or 24.4 inches, right? The diameter is all the way across. The radius is just from the center to the edge. So that's the radius. All right, so let's see here. Where did the picture go? The area would be pi, and we can use 3.14, or I don't know about what calculator you're using, but let's see here. This particular calculator has a pi button. It's the fourth one down right about there. I don't know if you can see it, but so you can either use 3.14 or if your calculator has a pi button. So then this is going to be what? 24.4 squared. Okay. So 3.14 times 24.4 squared. And it says round to the nearest square inch. So I'm getting 1869.4304. So the 4 would round down, so 1,869 square inches. That would be using 3.14. Now, if I use the pi button, pi is approximately 3.14, but in actuality, it's 3.14159 and goes on and on and on. I noticed the book has the answer as 1,870. So I'm going to go back and use the pi button instead. So pi times 24.4 squared. So pi times 24.4 squared. And now I get 1870.378602. So that's going to give us 1870 square inches. So by using the pi button, since this is a little bit more than this, that increases our answer. So hopefully you could find a pi button on your calculator. And if you're having trouble finding it, let me know either now or office hour or whatever, and we'll take a look at that. But any questions there? Okay. Here's another one involving a circle. It says horses. A horse trots in a circle around its trainer at the end of a 28-foot long rope. So the trainer is here. The horse trots in a circle around the trainer, and the rope is 28 feet long. So is the 28 feet the diameter of the circle or the radius of the circle?
The radius.
Excellent. So the radius is 28 feet. Find the area of the circle that is swept out. So covered by this. So the total area is pi r squared. So pi times 28 squared. I'm going to go ahead and use the pi button this time. So pi times 28 squared. And I get 2463.00864. Let's see, it says round to the nearest square foot. So that would be right there. The 0 would round down. So 2,463 square feet would be the area. Okay, any questions there? Here's another example. It says softball. The strike zone in I can't talk, nothing new there. The strike zone in fast pitch softball is between the batter's armpit and the top of her knees as shown. All right, and they've got a box drawn. And I won't try to draw the batter next to it. You'll be thankful that I don't try and draw it. It says, if the area of the strike zone for this batter is 442 square inches, what is the width of home plate? So basically what they're doing, they're giving us a rectangle, they're giving us this length and asking us to find that width or that length, okay? The area of a rectangle is length times width. So 442 equals 26 times W. Now, we could get into a discussion about is the 26 inches the length or the width, but let's see. They asked for the width of home plate, and so that would be, so this would be the width and that would be the length, okay? Dividing both sides by 26, whoops. Crossed out the wrong thing there. Let's see. 442 divided by 26 is 17 inches. So the width of home plate is 17 inches. Okay, well, that's what I've got for you today to wrap up section 2.4. I will be back this afternoon at 1:15 with an office hour. So just to kind of let you know where we're at, let's see here. We won't actually have our test until a week from this Friday. And this coming Monday is Martin Luther King Jr. holiday, so there'll be no class then. And I'll remind you of all this, but it's there in your syllabus for those of you that look at it, which obviously I didn't look close enough the other day. That's why I went too far. But anyway, so wrap up section 2.4 today, and I will see you tomorrow, if not this afternoon. And with that, I shall stop the recording.